Why does Saturn have 83 mysterious moons? Until a few weeks ago, Saturn was the planet with more moons, totaling 83. However, it was dethroned when 12 new moons were discovered orbiting Jupiter, making Jupiter the planet with more moons. But Saturn is much smaller than Jupiter and still has many objects orbiting around it. What mysteries do Saturn's moons hide? Let's find out. Although the current count of satellites around Saturn totals 83, the reality is that this number is still open to debate. The largest satellite is Titan, the only satellite in the solar system with an atmosphere containing substances in a liquid state. There is also Enceladus, a satellite that could have an ocean of liquid water beneath its ice sheets. How many types of satellites are there? Saturn's satellite system offers the most extensive variety of exciting examples of orbital dynamics, such as co-orbital satellites, Trojan and Shepherd satellites, satellites with retrograde orbits, and even satellites in resonance with each other. The satellites known before the start of space research are Mimas, Enceladus, Tethys, Dione, Rhea, Titan, Hyperion, Iapetus, and Phoebe. These are the biggest. In 2004, 12 new satellites were detected, whose orbits suggest that they are fragments of larger objects captured by Saturn, and whose existence has been confirmed by the Cassini-Huygens mission. This mission also discovered several new satellites. On April 15, 2013, the Cassini probe photographed disturbances in Saturn's outer rings, and it recently became clear that a new satellite was forming. That detected object, which measures no more than half a kilometer, was baptized as Peggy. Why so many? Based on data astronomers have collected over hundreds of years, Saturn's moons are thought to have formed when larger bodies collided, sending debris in many directions and getting trapped in their orbit in the form of natural satellites and asteroid rings. Over millions of years, this debris became the moons we know today, and they still collect material passing through space. Due to the dynamics of the asteroid belt around Saturn, it is theorized that the moons grew in size because they picked up particles in Saturn's ring. Saturn's 82 moons are divided into 10 groups. Those are Shepherd satellites, co-orbital satellites, large inner moons, Alcyonide satellites, moons of Troy, large outer moons, irregular moons, which in turn are divided into Inuit group, French group, Nordic group. Number 1. The Pasteur satellites. Small moons orbit within or beyond the planet's ring system. These significantly affect the shape of the rings and are responsible for sculpting them, giving them sharp edges and creating spaces between them. Saturn's shepherd moons are Pan, Daphnis, Atlas, Prometheus, and Pandora. These moons and the co-orbital ones form due to the accumulation of ring material. The name of these satellites is an analogy to sheep herders, who are responsible for guiding the flock in the direction they wish, in the same way shepherd satellites guide objects around them. Number 2. Co-orbital satellites. In this group are the satellites Janus and Epimetheus. They are about the same size, with Janus slightly larger than Epimetheus. Both have orbits only a few kilometers apart on the semi-major axis. Confusion occurred when they were first observed because astronomers thought it was a single satellite. Both satellites are close enough to collide, but this does not happen since being gravitationally anchored instead of colliding, their gravitational interaction causes them to change orbit every 4 years. Large inner moons. Saturn's innermost large moons orbit within its faint E-ring and 3 smaller moons from the Alcyonides group. Mimas is the smallest and least massive of the inner-round moons. Although its mass is enough to alter Methone's orbit, Mimas has no known present or past geological activity, and impact craters dominate its surface. Number 4. Alcyonide satellites. In the Alcyonides group, 3 small moons are orbiting between Mimas and Enceladus, Methone, Anthea, and Pallene. Named after the Alcyonides of Greek mythology, they are some of the smallest moons in the Saturn system. These are characterized by having little mass, and because of this, they do not have spherical shapes. Number 5. Moons of Troy. The moons of Troy are a unique feature only known in the Saturn system. The Saturn system contains two sets of Trojan moons. Both Tethys and Dione have two Trojan moons each. Tethys has Telesto and Calypso, while Dione has Helene and Polydeuces. These satellites orbit at Lagrange's L4 and L5 points and therefore remain gravitationally anchored to Saturn, Tethys, and Dione. Number 6. Large outer moons. These moons orbit beyond the E-ring, where Rhea is Saturn's second largest. But the largest is Titan, with 5,149 kilometers in diameter. It is the second largest moon in the solar system, only surpassed by Ganymede. Of all the large moons, Titan is the only one with a dense cold atmosphere composed mainly of nitrogen with a small fraction of methane. Titan is one of the most complex celestial bodies in the solar system. More about it later. Number 7. Irregular moons. Irregular moons are small satellites with large radii, inclined and often retrograde orbits, which are thought to have been acquired by the parent planet through a capture process. The exact size and albedo of irregular moons are not known for sure because the moons are too small to be resolved with a telescope. Number 8. Inuit group. The irregular group moons are divided into 3, starting with the Inuit group. It includes the 7 outer moons, Igirak, Kiviuk, Kaliak, Cyrenaic, and Tarkek, along with 2 unnamed moons. The largest of them is Cyrenaic, with an estimated size of about 40 kilometers. Number 9. Gallic group. This group of irregular moons is made up of 4 outer moons. They are Albiorix, Bibine, Areapis, and Tarvos. The largest of these moons is Albiorix, with an estimated size of about 32 kilometers. Number 10. Nordic group, or Phoebe. This is the largest group, consisting of 46 retrograde outer moons. Natural satellites with retrograde orbits orbit in the opposite direction to the planet's rotation. It is known that these types of satellites have retrograde orbits because they were initially asteroids, but then passed close to the planet and were captured by gravity, remaining in orbit around it but in the opposite direction to the rotation. That is why these types of satellites are always little ones. The largest of this group is Phoebe, followed by Ymir, with an estimated diameter of only 18 kilometers. Phoebe was the first moon of Saturn to be studied in detail by the Cassini probe in June of 2004. During this encounter, Cassini could map nearly 90% of the moon's surface. It is currently known that this satellite serves as a source of material for Saturn's most giant known ring. Most important moons for space exploration. Of the 83 known moons of Saturn, only 5 exceed 1,000 kilometers in diameter. These are Titan, Rhea, Iapetus, Dione, and Tethys, followed in diameter by Enceladus and Mimas. Thanks to the various observations made over the years, we know that water is in the form of ice on Titan and Enceladus, 2 critical candidates for finding microbial life. Among these satellites, we have Rhea, which stands out as the only natural satellite in the entire solar system with its ring system. The ring's existence was deduced by observed changes in the flow of electrons trapped by Saturn's magnetic field as Cassini passed through Rhea's vicinity. Debris and dust could extend to Rhea's Hill sphere, but were extended to have more density in the satellite's vicinity. The presence of the ring was reinforced by the subsequent discovery of a set of small spots, bright in the ultraviolet, distributed along the equator of Rhea and interpreted as places of impact of materials coming from the ring. Although today the existence of this ring remains in doubt, since when Cassini made specific observations in the supposed plane of the ring from different angles, it found no evidence of its existence. The oceans of Enceladus. Enceladus is Saturn's 6th largest satellite at just over 500 kilometers in diameter. It is covered by a layer of recent and clean ice that reflects almost all the sunlight that falls on it, so the surface temperature is very low, only reaching minus 198 degrees Celsius at noon. Despite its small size, it has a wide variety of surface features, ranging from ancient and characterized regions to young, tectonically deformed terrain formed just 100 million years ago. Like Saturn's largest satellites, Enceladus rotates synchronously along with its orbital period, leaving a face always pointing towards Saturn. The Cassini space probe disintegrated in December of 2017. Among its feats, it highlights the discovery of a column of water similar to a geyser, which was ejected into the atmosphere from below the icy surface of Enceladus. The characteristics of the water column suggested the presence of hydrothermal activity. Scientists believe that Enceladus and Europa, one of Jupiter's 4 Galilean satellites, appear to have liquid oceans and hydrothermal activity under their respective ice crusts. These 2 moons are suitable places to search for potential life because water interacting with rocks on the seabed could produce chemical reactions that would enable microbial metabolism. Before we move on to the exploration of Titan, be sure to stay tuned afterwards if you haven't seen our earlier release on Saturn's moon Enceladus could have signs of life. Titan, Earth's distant cousin. Titan is the largest of Saturn's satellites and the second in the solar system after Ganymede. In addition, it is the only known satellite to possess a significant atmosphere. Saturn's largest satellite is often described as a planet-like satellite. It has a diameter 50% larger than the Moon and is 80% more massive. It is more significant in volume than Mercury and has a denser atmosphere than Mars. Titan is composed mainly of ice and rocky material. As with Venus before the space age, Titan's dense and opaque atmosphere prevented understanding of its surface until the arrival of the Cassini-Huygens mission in 2004. Thanks to this mission, it was discovered that this natural satellite has immense lakes of liquid hydrocarbons in the polar regions. The surface is geologically young, despite the mountains and the discovery of several possible cryovolcanoes. Titan's surface is smooth and has few impact craters, indicating that it has a vibrant, constantly renewed atmosphere. According to available data, Titan's atmosphere could be composed mainly of nitrogen, but up to 6% may be methane and complex hydrocarbon compounds. Climate, including wind and rain, creates Earth-like landforms such as dunes, rivers, lakes, and seas, probably liquid methane and ethane, and is dominated by seasonal weather patterns as on Earth. Many scientists believe that Titan looks like Earth did 4 billion years ago, making it the most promising candidate for finding possible life forms beyond Earth. From whether the moon known as Enceladus honestly has the potential for life to what we could do if it honestly has it and more, join us as we explore how Saturn's moon Enceladus could have signs of life. The search for life beyond Earth has been one of the most in-depth searches that NASA and other space agencies have done in the last several decades, not the least of which is because as we've gone and grasped the true vastness of space, it feels almost impossible that there isn't some kind of life out there amongst the stars. To be clear, many aren't saying that it has to be humanoid life or even animalistic style life, but just life in general. As such, as we look at the various planets and even the moons that surround them, we look for anything that could give us a hint that there is indeed life out there, which brings us to Saturn and one of its many moons. In 2005, NASA's Cassini-Saturn orbiter discovered geysers blasting particles of water ice into space from tiger stripe fractures near Enceladus' south pole. That material, which forms a plume that feeds Saturn's E-ring, the planet's second outermost ring, is thought to come from a huge ocean of liquid water that sloshes beneath the moon's icy shell. This discovery on its own was special because it meant that there might just be water on this moon. And if there's water on it, there's a chance we can colonize the moon, as it would allow us to have easy-ish access to water. But a deeper look at the plume itself revealed things that weren't expected. For example, dihydrogen, H2, and a variety of carbon-containing organic compounds, including methane, CH4. The dihydrogen and methane are particularly intriguing to astrobiologists. The H2 is likely being produced by the interaction of rock and hot water on Enceladus' seafloor, scientists have said, suggesting that the moon has deep-sea hydrothermal vents, the same type of environment that may have been life's cradle on Earth. For those of you that don't know, the hydrothermal vents that are indeed life forms that live there in a way that has often boggled the minds of scientists as a whole, not the least of which is some entities are able to go and perform photosynthesis without even needing light because they have the heat and other chemicals coming from the vent itself. So thus, if a similar vent can be found here on Enceladus, that would mean that there could honestly be a kind of microbial life form on the moon, and obviously scientists would be very interested in that. We wanted to know, could Earth-like microbes that eat the dihydrogen and produce methane explain the surprisingly large amount of methane detected by Cassini? Study co-lead author Regis Ferrier, an associate professor in the University of Arizona's Department of Ecology and Evolutionary Biology, said in a statement. So Ferrier and his colleagues built a series of mathematical models that assessed the probability that Enceladus's methane was generated biologically. These simulations were diverse. The team investigated whether the observed H2 production could sustain a population of Enceladus microbes, for example, and how that population would affect the rate at which H2 and methane escape into the plume, among other things. In summary, not only could we evaluate whether Cassini's observations are compatible with an environment habitable for life, but we can also make quantitative predictions about observations to be expected should methanogenesis actually occur at Enceladus's seafloor, Ferrier said. Now, before you all start celebrating that life has been discovered, you need to take a step back and realize that these were mainly theoretical equations and suggestions based on the science that we know works on Earth. Even the team behind this potential groundbreaking discovery aren't saying that they found life on a moon of Saturn, but merely that there is a possibility of it. They even noted that there is a chance that excess methane is due to how certain things work on the moon, in contrast how they work on Earth. It partly boils down to how probable we believe different hypotheses are to begin with, Ferrier said. For example, if we deemed the probability of life in Enceladus to be extremely low, then such alternative abiotic mechanisms become much more likely, even if they are very alien compared to what we know here on Earth. That being said, biological methanogenesis appears to be compatible with the data, Ferrier said. In other words, we can't discard the life hypothesis as highly improbable. To reject the life hypothesis, we need more data from future missions. And that right there is the key word, more data from future missions. Because as exciting as it is to go and try to say that they have found life on the moon of Saturn, they can't prove it for various reasons because, well, we aren't there. Yes, we've had probes to go and get there, but we ourselves have not been to Saturn, and it doesn't look like we'll be able to go there soon based on our own restrictions in terms of space travel. However, should this theory be tested, it could prove a lot of things about not just space, but our own solar system. Think about it, if these kinds of microbial life forms are found on the moon of Saturn, what other moons out there could possibly have a similar thing? Plus, if there is one kind of life on this kind of moon, who's to say there won't be another on a different kind? The irony here, though, is that technically this isn't the first time that people believe that there was life of some kind on Enceladus. Let's now rewind the clocks back to 2019, where scientists claimed that they found the building blocks for life on the surface of Enceladus, before realizing that the compounds they came from were, once again, from the waters underneath the moon. If the conditions are right, these molecules coming from the deep ocean of Enceladus could be on the same reaction pathway as we see here on Earth. Nozer Khawaja, who led the research team behind the discovery, said in a release, "We don't yet know if amino acids are needed for life beyond Earth, but finding the molecules that form amino acids is an important piece of the puzzle. Here we are finding smaller and soluble organic building blocks, potential precursors for amino acids and other ingredients required for life on Earth," John Hillier, another co-author of the study, said in a statement. So if these two things are to go and be believed, that means that in potential we have two different ways that life on this moon could exist. That's something special right there. Of course, the problem here is, again, data. It's easy to go and look at things because of the probes that have orbited the planet and its moons for a while, and make guesses as to what is there and what isn't. But if you're going to go and make a definitive declaration about something like life, you need to go and get the definitive proof. Whether that happens soon or not is very much up for debate for a host of reasons, not the least of which is that it's a long way to Saturn and its moons. The mission project would take a while to plan, to say the least. Then you'd have to outfit something like a rover or specialized craft to be able to go into the moon, presumably via through one of its geyser pits, and then take samples of both the water in certain places and even potentially go into the vents of the moon itself to get the key samples. Then said craft will have to return to the surface and then fly back to Earth. If that sounds like a lot, it's because it is. That's a lot of work for a singular craft to do, not to mention it would have to be done via a controller back on Earth. And so that's a lot of potential for things to go very, very wrong. But do we give up on this? No, of course not, especially if there is indeed a potential for life on the moon. It just means that NASA and its various other allies in the space agency business will need to get creative in order to make things work. It won't be easy, and there will likely be a lot of failures. But if done right and the patience is there, again, it'll be a long trip to Saturn, they could make it work and make a discovery one way or another. And for NASA, that's a victory in and of itself. Now, some would go and say, why can't you just do a piloted mission to Saturn? Well, that's an even longer experience, sadly enough. Let's put it to you this way. When they did the Pioneer 11 mission, it took that probe 6.5 years to go and reach Saturn. And that was just a probe, something that didn't have a lot of mass and other things to weigh it down. Many projects that at best it would take humanity at the current technology level about 8 years to go and get to Saturn, let alone one of its moons. And to be clear, that's with Saturn at its closest to Earth in terms of their orbits around the Sun. If you try and launch at the wrong time, it'll likely take you a lot longer. It's true that companies like SpaceX and others are trying to develop rockets that will take us to places like Mars and Saturn faster, but it won't be that much faster. We can only do so much with the technology that we have right now. As a result, we can only use what we have, and that means probes and satellites. They may not get us all the answers we need, but they're what we're going to rely on. And as mentioned earlier, with this potential for life on one of Saturn's moons, it has over 80 of them, it makes you wonder, and people at NASA wonder, what else these moons could be housing. Because it goes to reason that if one of these moons have the condition for a kind of microbial life, so does some of the others. For example, the moon, Titan, has been touted by many to be a better spot for human colonization than Mars, and it too has all sorts of methane spots via massive lakes. True, there haven't been any indications that life in any way is causing this, but what if it is? Or what if one of the many other moons of Saturn that have this kind of potential? That could lead to all sorts of wonders. Not to mention, Saturn isn't the only one with moons. Jupiter has dozens. Mars has a few that have been heavily studied, and there are plenty of moons throughout the universe that might have certain conditions. So while all of this is theoretical at present, the potential is just as exciting as we might learn more about the universe through this one moon. Thanks for watching, everyone. What do you think of this look at Enceladus and how its waters might honestly have a type of life within it? Do you think we'll ever get a definitive answer as to whether it really does have life? Or will we keep guessing as we try and figure out it all from afar? Do you think that humanity will ever reach Saturn on manned missions? Let us know in the comments below. Be sure to subscribe, and we'll see you next time on the channel.